Minatsa Duamnilor, Shi Duamnilor, is correct? Unfortunately, these are my only Romanian words. Thank you very much, Daniela, for your introduction. Yes, I'm going to speak about the last year as a special year. I need my remote. And also about things which happened already this year to figure out whether there is a trend to ever more records of losses. We have heard from the State Secretary that Romania has been affected very much and that climate change is real here with even higher increases of temperatures compared to the average. Here you see just an overview of what has happened last year in terms of the loss-relevant events. This is data from the Munich Green NatCat Service database. There are 710 loss-relevant events have been registered. You see the larger dots, which are the major catastrophes. You see quite some in North America with the hurricanes, with wildfires. We also see wildfires in Europe. You see earthquakes all over the places. Actually, you will get the chance to download this presentation, and you can have a closer look to that. What's very interesting is the trend, and there is a clear trend. So since the early 1980s, since we have these reliable data, we clearly see that on a global level we have more events which cause relevant losses. And these trends are driven primarily by the weather-related events. The red bars show the geophysical events, which are earthquakes, tsunamis, volcano eruptions. There you don't see that trend, but you see the trend for the storms, the green bars, the floods, the blue bars, and the other weather-related events like wildfires, droughts, the yellow or orange bars. So we see a trend upwards. Last year hasn't been a record year in the number, but it has been the year with the third largest number of events. But if we look at the losses, if you look at the inflation-adjusted losses as you see them here, total losses in green and insured losses in blue on a global level, again, for the weather-related ones, then you clearly see that last year has been the absolute record year. Never before the losses have been as high, more than 300 billion, 330 billion US dollars in total losses, and little less than half of that has been insured. You see 2005, the year with the second largest losses, and I will get into detail. Both of these years have been dominated by hurricanes making landfall in the US and causing these tremendous damages. What you see here is the natural disasters 2017 in relation to the year before, 2016, and the long term, and you see this 330 billion US dollar losses. The figures of 2016 had been 184, and the average of the last 10 years is just 170 billion, and the average of the last 30 years is 130 billion. So this has been an outstanding year, also in terms of the insured losses, 135 billion US dollars insured losses last year. The long-term or last 10-year average is less than 50 billion. So what has contributed to that? Especially 3 hurricanes have contributed to these tremendous losses, starting with Hurricane Harvey, which has caused extreme floods in the Houston area, especially there you see the track. And this in total, Harvey has caused total losses of 85 billion US dollars, and by this it has been the second most expensive hurricane in history right after Katrina. Then Hurricane Irma followed in September last year. It has been the 4th most expensive hurricane in history with 67 billion US dollars total, about half of that insured. This is a typical insurance penetration ratio in the US. And there you see Hurricane Maria, which has been the 5th most expensive hurricane with a total loss of 63 billion US dollars. If you put now the hurricanes of last year in the top 10 ranking, which has been set up previously before last year, then you see that Harvey made it on the second place, and Irma and Maria on fourth and fifth place. So just in 1 year, 2017, we had 3 out of the 5 most expensive hurricanes in history, and this is something very outstanding. Here you see the hurricane losses, and you see that for the total losses, the hurricane losses have been the highest last year, so this has been, as already said, the major contribution. The second highest, again, 2005 with hurricanes Katrina, Wilma, and Rita. And there is clear evidence from scientific studies, from climatological studies, applying climatological models to figure out how the conditions for hurricanes will change, because the atmosphere is warming up, and they show, for example, or expect a doubling of the frequency of the strongest of the category 4 and 5 storms by the end of the 21st century. One of the drivers certainly is increased humidity, which is the fuel for these systems. And there's another factor which increases the losses caused by hurricanes or typhoons, how they are called in the Northwest Pacific Ocean. And this is sea level rise. If you have a higher sea level, the storm surge is higher and causes more losses. And Lloyd's, for example, has calculated for Hurricane Sandy, which has caused tremendous losses in the New York City area, in New Jersey, that alone the 20 centimeters of sea level rise, which we already have due to climate change, has contributed to an increase in the losses of Sandy, of the storm surge caused by Sandy, by 30%. And 30% in this case is billions of dollars. So billions of dollars already can be attributed to sea level rise and by this to global warming. What you see here is the 5 largest natural disasters in last year, and there you see these 3 hurricanes. You see, and this is now by insured losses, where you have a higher contribution of the windstorm part compared to the flood part. This is why here Harvey is only second and Irma is first. Then we have Hurricane Maria, and then we have another 2 events in the US, wildfires in California and hailstorm in the Midwest. So the year has been a record year, and most of the high losses occurred in North America. What have been the relevant loss events in Europe? There has been a late frost event after a very warm period, and this is also what we see, that spring starts earlier, it starts earlier to warm up, and the vegetation phase starts earlier, and then if there is a frost afterwards, then this causes a lot of damage. And last year this has reached a level of 3.3 billion euros. Only 600 million euros have been insured of that. So it's agricultural losses, especially the farmers had to suffer a lot from that. Crops had already grown robustly in an otherwise warm spring and have been affected. Depending on the region and particular fruit, harvests were up to 50% smaller than usual, and this has increased even the prices for that. Relevant natural losses or such events definitely have to be expected more often, because, as I already said, the vegetation phase starts earlier in the year, and so the plants are more vulnerable towards or against these late frost events. 2018, this year, has shown a lot of thunderstorms and heat and drought in Europe. We have just heard from the State Secretary that also Romania has been affected by such thunderstorms, and also more frequently has been affected by droughts. We had unusual weather patterns in Central Europe in May and early June. In Germany and France, a series of very slow-moving thunderstorms. Slow-moving means that they can pour down a lot of precipitation at a small region, and this can cause flash floods in the area. So in many places, the losses have reached, as you can see here, 1.6 billion euros, and a lot of that insured because Western Europe has been affected, and a lot of these damages have been caused by hail, which normally is insured in these countries. In Northeast Germany, Denmark, Poland, Scandinavia, and the Baltic states and the Balkans, they experience very high temperatures, extremely dry weather, so grain harvest has been very poor in many of the affected regions. And the reasons for both phenomena was stable weather pattern, featuring a blocking high pressure area over Scandinavia and an expansive low pressure system stretching from western to central parts of Europe. And we see more of these weather patterns because we see a destabilization of the so-called jet stream. And this is an effect of melting ice and snow in the Arctic. So there is again some link to climate change, that these stable patterns, which can mean heat and drought in one region and a lot of precipitation and flooding in another region. So climate model studies show that one future effect of the increases in temperatures will be more frequent periods of heat and drought, along with more intensive convective rainfall, which means thunderstorm-related rainfall. These are the 5 largest natural disasters in the first half year of 2018 of this year, ranked by the insured losses. So it starts with a winter storm in Europe, which has affected primarily France, Belgium, Netherlands, and Germany. 2.7 billion US dollars, the total losses. Then winter storm in United States, severe storms in United States, again on rank 3 and 4. And in Europe, then we have seen another winter storm, which has 2 different names, Brooklyn and Eleanor, has affected Ireland, UK, France, Belgium, Netherlands, Germany, and Switzerland, with also more than $1 billion losses. And what we also have seen, and this is in the second half of this year, we have seen Florence, a hurricane which has caused a lot of damage in South Carolina and neighboring states. The rough estimates of the losses are in the range of about 10 billion US dollars, and a similar range of losses caused by a typhoon which has hit Japan recently. But if you add this all up, the year 2018 is totally different from 2017 by now. It's a real low loss year compared to the losses of the last years. But this is part of the story, that we have a high volatility in these losses. Let's have a look at some changes on the heat side and also on the convective storm side after that. There is a higher frequency of temperature records. This is proven by analysis of the routine measurements of the meteorological stations, and there is one study which has analyzed the frequency of record temperatures measured at these sites, and the study has resulted in the assessment that the number of local record-breaking monthly temperature extremes is now on average already 5 times higher compared to what we would expect if we would have a stable climate, if we wouldn't have global warming. And this year has brought a lot of temperature records. I just have a few examples, starting in northern Africa, Algeria and Tunisia, with temperatures above or close to 50 degrees than Turkmenistan. Los Angeles has set a new temperature record. Never before they had as high temperatures, 43.9 degrees in Portugal. They had much more than 40 degrees. Japan, Kyoto has had a new record close to 40 degrees. And even in Ireland, in Scotland, they had hot days, 32 degrees. In Glasgow, 31.9 degrees. This is just a few examples of the many heat records we have seen this year, and especially Western and Northern Europe had been affected by the heat, and this is the anomaly of the July temperature this year, and you see these darker orange areas. There they had 6 to 8 degrees higher monthly average temperatures in July than on long-term average. So this has been an extreme summer in this respect, and there has been an analysis done by Friederike Otto. She works at the Oxford University, and she does so-called attribution studies. So she calculates the probabilities of these extreme events with and without climate change, and her result has been that this heat wave, which we have seen in Europe this year, is twice as likely already because of climate change. So this is another piece of evidence that climate change is already changing things. Another, I think, quite impressive example how things have changed already and are changing is the temperature curve, or the curve trend of numbers of days with temperatures above 30 degrees. In this case, it's where I live in Munich, and this is measured at the Meteorological Institute at the university, so they do really high standard and high quality measurements. And you see that while in Munich in the 1980s, only on a few days the 30 degrees have been transgressed, in some years only one time, or up to 10 times, and then in the 1990s up to 15 times, and you see that especially the last years, 2015, 37 days above 30 degrees, then 2017, 33, and this year we are at 33. So you see there is clear evidence that we are living in a different climate. The state secretary has said here in Romania, the annual average is already close to 2 degrees higher compared to before the emissions of the greenhouse gases. Now let's have a look at the convective events, which means thunderstorm-related events. It could be tornadoes, it could be hail, it could be intense precipitation, and especially Romania, as you have learned, is also affected by these things. The most expensive of such events has occurred in Germany, interestingly, in 2013, with 2 lines of hailstorms, one from Lower Saxony to North Rhine-Westphalia, and the other one in Baden-Württemberg. These hailstones have reached diameters up to 11 centimeters. A tennis ball has a diameter of 7 centimeters. And in total, this has caused losses of 3.6 billion euros. Just these 2 lines of hailstorms. Insured losses 2.8. You see how well people are insured in Germany against hail. And another similar event happened, so this was 2013, and now we are in 2016 in the Netherlands, and you see the formation of the clouds before this hailstorm started. You see the hailstone here on the right picture, and again, this has been a $1 billion loss event, 1.3 billion euros, total loss 650 million insured, especially the greenhouses, which are quite popular in the Netherlands, as you know, have been destroyed to a high degree. And again, there is clear evidence that convective storms, thunderstorms, intense thunderstorms, are increasing in frequency. Here you see the worldwide, the number of relevant events, and this has gone up even farther compared to the general trend of weather-related natural disasters. And also the losses have gone up, and here you get some additional information. You get the so-called normalized losses. Let's start with the gray bars. These are the nominal losses, the losses at the time when the event occurred. The green line is the inflation-adjusted losses, and the red line is the normalized losses, which means there it has been calculated how a historical event, or to what loss a historical event would lead if it would happen with the exposure of values of today. So if you look at the red line, you clearly see that there is a trend upwards. There have been some events in the 1980s, especially in 1984. There has been a hailstorm crossing right over the city center of Munich and having caused a lot of losses. But you see, especially in the last years, there is a concentration of these high loss events. And there are more and more studies, and I'm going to introduce you two studies which have been done at the Geo-Risk Research Department Munich Re together with some PhD students. The first one has concentrated on the US, and they are published in scientific papers and journals. So they found increase in humidity is driving larger variability and intensity of convective events in the US. And just recently, just 2 months ago, a new study has been finished now focusing on Europe. So the PhD student has analyzed the meteorological conditions in the last decades in Europe and the loss patterns, and also has applied climate models to figure out how these things are going to change in the future. And they detected an already existing trend to more thunderstorm-related loss events in Europe, with the exception of Southwest Europe, where it's too dry for this kind of events. And the model results show further future increases of these hazards caused by convective events in Central and Eastern Europe. So Romania definitely is one of the countries which will be affected much more by these thunderstorm-related events. Yeah, let's finish this analysis by showing you some figures of the state of the climate. You have certainly read in the newspapers or seen in the news that IPCC has released a new report just yesterday, has released a report on whether it's still probable to keep global warming below 1.5 degrees and what has to be done. And this report really tells us that it's urgent to act, because climate change is proceeding much more rapidly compared to what the scientists have thought before. What you see here is the temperature anomaly starting in 1880 in respect to the average of the last century, and you see the last years have been by far the warmest years. The last 4 years have been the 4 warmest years since we have reliable measurements. And this is the state of the climate for this year, 2018. By now, January through August, this is where we have the data already. You see here in relation, the temperature anomaly in relation to the mean of 1981 to 2010. And this mean is also already influenced by climate change. And you see that all of Europe has been warmer. In these first 8 months of the year. There are only a few areas with blue colors where it has been a little colder. So the first 8 months of 2018 have been the 4th warmest since records started in 1880, and 17 of the 18 warmest years on record occurred in the period of 2001 and 2017. The largest problem in respect to weather extremes is not the air temperature, it's an effect of rising air temperatures and rising ocean temperatures. It means more evaporation from the warmer water surfaces. It means that the atmosphere can take up more water vapor, more humidity, and this water vapor brings more energy into the weather machine, and it also increases the potential for intense precipitation events. In the last IPCC report, the regular fifth assessment report, the researchers found that increasing sea levels will lead to increasing problems for people living in coastal areas, that we will see more people being affected by droughts, water scarcity, but on the other hand, also by more flooding. This is no contradiction to global warming. Global warming will bring both, and more frequent and or severe weather events are projected for some regions, and the losses will increase. And even in this climate research paper or book, you find a reference to insurance. Changing patterns will challenge insurance systems to offer affordable coverage, provide more risk-based capital. I think we will have a chance to discuss this at the panel session after the coffee break. So I get to my conclusions. As I have shown you, 2017 has set new records for total and insured losses caused by weather extremes, dominated by hurricanes and wildfires in the US. And the long-term global loss data show a clear trend to more frequent loss events, higher losses. The loss level of 2017, however, is a clear outlier. This has to be said. Climate change is one of the drivers to higher weather and related losses, especially for tropical storms, which are the hurricanes, the typhoons, the cyclones, as well as for thunderstorm-related events and heat-related events. Until now, the losses in 2018 have been well below the long-term averages, even though many new extreme weather records have been recorded. The record loss year 2017 cannot be characterized as the new normal. It's an outlier, but the insurance industry has to take into account a general trend to higher losses caused by weather extremes on the long run. Thank you very much for the invitation to your conference and for your interest.